Hello everyone, it's Mr. Miller here again. I hope you're enjoying your day off school today, or if you're watching this on the weekend, hope you're enjoying your weekend. This is the second video I've made on the 2017 Paper 2 video. So before you watch this video, and you may choose to watch the whole thing or just specific questions, obviously please make sure that you have spent 60 minutes to 90 minutes, the whole paper you have 90 minutes, doing the actual paper, and then mark your work using the mark scheme before watching this video. It's okay if you want to watch the whole video, that's fine, but there's no point watching this video unless you have tried the questions first. Same as last time, I'm going to cover all the questions, but this time I think it would be helpful. I've added at various different questions some Corbett references. So if you got the question wrong, you can go to the video on Corbett Maths. You can watch the video, you can try some additional practice questions to help you with that topic. So let's go ahead on question 1 to start off. So the table shows the probabilities that a biased dice will land on 2, 3, 4, 5, and 6. So we've got a table there. Immediately I can see that the probability is not there. Name our rolls of the biased dice 200 times. Work out an estimate for the total number of times the dice will land on 1 or 3. Okay, so a sensible start would be, I think, step 1, find the probability of getting a 1. So we know that all of these probabilities sum to 1. All of these probabilities sum to 1. So let's add up the ones that we've got. I've done this paper already, so I don't have to waste time putting things into my calculator. So those sum to 0.69. So take that away from 1, and I get 0.31. So I can add that to my table. And it's worth saying, I'll say this at various points, that even when you're putting something into your calculator, you should still show what you're putting into your calculator on your page. So step 2, so it says work out an estimate for the total number of times the dice will land on a 1 or a 3. So it could land on a 1, so I'll box that, could land on a 3. So the probability of 1 or a 3, I'm going to add those together. 0.31 plus 0.18, which is 0.49. And then final step, I'm rolling the dice 200 times. So I know that to get my estimate, I'm going to do my probability, 0.49, multiplied by 200, and I get an answer of 98. So nice way to start the paper with a probability question. Let's keep going. Okay, question 2. So quite a lot of words here, but actually I know that the more words there are in the question, the easier the math. So not going to panic. Let's look at this question. So on Saturday, some adults and some children were in a theatre. Okay. The ratio of the number of adults to the number of children was 5 to 2. So before reading on, I'm just going to write down adults to children. I'll use A for adults, C for children, 5 to 2. And I've already written down something which is good. So each person had a seat in the circle or had a seat in the stalls. Okay, so I don't know how many are going to be in the circle, how many are going to be in the stalls, but I know it's either going to be circle or stalls for the adults, and same for the children. So either going to be circle or it's going to be stalls. Okay, 3/4 of the children had a seats in the stalls. 117 children had seats in the circle. Okay, so now let's just have a look at children, and let's write down what I've got. So I know they're going to either be in the circle or they're going to be in the stalls. And I know that 3/4 are in stalls. So I can work out what fraction of them are going to be in the circles. And obviously that's 1/4. Great. So we've got 1/4 to 3/4. And what else do I know? I know that 117 children had seats in the circle. So I think that 1/4 is equivalent to 117. Now, can I work out something else? Yes. I think I can work out how many children are sat in the stalls. How do I get, what's my scale factor from 1/4 to 3/4 times by 3? So 117 times by 3 is 351. So now I can work out my total by adding them together. So add them together, 117 plus 351 equals 468. So that is the total number of children that I have. Okay. Now let's go back and have a look at my ratio of adults to children. And I'm going to write that down again, 5 to 2. And I know this time that there are 468 children. So again, I can work out my scale factor from 2 to 468. It is times 234. I can use my calculator for that. So times 234, and I get 1170. Great. So now I think I can work out the total number of adults and children. Adults and children. By adding them up. 1170 plus 468. Again, I'm writing down my working, even though I'm going to put it in a calculator. 1,630. Okay, I'm just going to do my final step off to another side. So let's just label the steps. My first step was finding out how many children there are. Second step, how many adults and children. Third step. Okay, there are exactly 2,600 seats in the theatre. On this Saturday, were there more children on more than 60% of the seats? Okay, so if I work out what percentage of the 2,600 seats that were occupied and then compare it to 60%, I can have my conclusion. So I know that there were 1,630 seats out of 2,600, and that's going to give me my percentage of seats that were available, 62.7%. That is more than 60%. So I think my conclusion is going to be, yes, there were people on more than 60% of seats. So actually the maths wasn't difficult there. What was slightly trickier was figuring out exactly what I needed to do and how to get to my answer. Let's move on. Okay, question 3, and this is the first question I put a Corbett reference on. So if you want to practice this more, if you struggle with this question, you can go to Corbett 354. So we haven't seen this question for a while, but we did do it in year 9, and we will recap it soon. So the diagram shows a prism with a cross section in the shape of a trapezium. On the centimeter grid below, draw the front elevation and the side elevation of the prism, and we're told a scale. So 2 centimeters to 1 meter. So 2 centimeters to 1 meter. Okay, so I've got to do both of these things. Let's start off with the front. This is definitely easier. So I'm just going to write front. And so we can see from the diagram, the front, we're looking at it sort of straight on. So we're going to see, I think, this shape here. We're going to see that shape there, that shape in red. But before I draw that on the grid, I need to think about my scale. So it says here 2 meters, and I know it's 2 centimeters to 1 meter. So how many centimeters is 2 centimeters going to be? Well, using my scale factor, this is actually going to be 4 centimeters. And so is this 4 centimeters here. And using a similar logic, 2 centimeters to 1 meter, that's my scale. Well, what's 0.5 meters going to be? Well, I think I divide by 2. So that is 1 centimeter. Okay, so let's draw that shape on the grid. So I'm going to start here, and I'm going to go down 4. So 1, 2, 3, 4, and then across 4. 1, 2, 3, 4. Up 1, so just to there, and then I draw a line across like that. So that is my front elevation. Now let's have a look at the side elevation, and I actually think this is a little bit trickier. So I'm going to just rub out the red line that I've done, change to a different color, so blue. So if I look at it from the side, I definitely think I'm going to see this rectangle here, but am I going to see anything else? Well, I think I am. I'm actually going to see more than that. I'm going to see above that because the shape continues above that. So I need to think about how far up I'm seeing. And how far up I'm seeing, I think, is just this, this 2 meters or the 4 centimeters. So let's first of all think about the bit that we see down here. So what's the scale? So 1 meter, that's just 2 centimeters. So I'm going to start off down here by doing 2 centimeters along and 1 centimeters up. And that is the shaded bit there. But I'm also going to see the shape above it if I'm looking at it from the side view. And I'm actually going to see in total 4 centimeters. So I need to go up 1, 2, 3 more. And that's what I'm going to see. So some of you might have forgotten to thinking about this extra thing that we can see on the side view. Let's move on. Okay, question 4. Ollie drove 56 kilometers from Liverpool to Manchester, 61 kilometers from Manchester to Liverpool. Okay, so immediately I am thinking this is going to be an average speed problem. Let's draw a table. So I've got Liverpool to Manchester, L to M, and then Manchester to Sheffield. And I think that is it in the question. Yeah, I think that's it. So then I can have my total journey. Okay, so when I'm doing these questions, I need 3 things in my column. I obviously need my distance. I need my time. And I need my speed. And I'm also going to draw up here my triangles. So distance, I need to remember, goes at the top. Speed, time below. Right, let's draw what I've got on the table. So Ollie drove 56 kilometers from Liverpool to Manchester. So that is a distance, 56 kilometers. And then 61 kilometers from Manchester to Sheffield. So 61 kilometers. And for the total journey, I just add those distances together. I'm probably going to use that later, 117 kilometers. I'm going to tick off those first 2 lines. The average speed from Liverpool to Manchester was 70 kilometers per hour. So that goes in speed, 70 kilometers per hour. And then Ollie took 75 minutes to drive from Manchester to Sheffield. So that's 75 minutes. Okay, I'm going to have to come back to that later, I think, because my speed is in hours. So I'm going to need to change that minutes to hours, but I'll do that later. Okay, step 1. Let's work out the time from Liverpool to Manchester. So the time, what's the equation for time? We'll use my triangle, cover up time. It is distance over speed. So 56 over 70, which if you put in your calculator, you are going to get 0.8. So that is 0.8 hours. Put that there. Now, the next thing, from Manchester to Sheffield, I can work out the speed, but actually I'm going to need to convert this time. So I need to convert 75 minutes into an hour. So what is 75 minutes? So 75 minutes, well, that is one hour, because an hour is 60 minutes, and 15 minutes. So the mistake that you might make, which I'm going to show you, because I think some of you might make this, is that to say it is 1.15 hours. But it's not that, so I'm going to cross that off. What is this 15 minutes? Well, how many minutes are there in each hour? There's 60. So that is actually 15 out of 60 of an hour. And if you simplify that, you get 1/4 of an hour. Now, 1/4 of an hour is 0.25. So I actually think that 75 minutes is going to be 1.25 hours. So you should be careful with your conversions there. Okay, let's put that in the table. That is going to be 1.25 hours. And I don't think I need to work out the speed from Manchester to Sheffield, because it tells me to work out his average speed for the total drive. So I'm not going to worry about Manchester to Sheffield. Well, how do I do that? Let's work out the total time. It's going to be 0.8 plus 1.25. Everything's in hours, so it's okay. That is 2.05 hours. And then final step is going to be my average speed. I know that is equal to my total distance over my total time. 117 divided by 2.05, which in my calculator, 57.1 kilometers per hour. Okay, so a bit of a tricky question with some conversions. You must make sure when you're doing these types of questions that everything is in consistent units, and when you're converting minutes to hours or hours to minutes or whatever it is, you think about carefully how you do those conversions. Okay, question 5. So I've got a picture of a triangle here. ABC and EDC are straight lines. EA is parallel to BD. And then I got some measurements. So I should definitely draw these measurements on straight away. I think it's going to be a similar triangles question because I've seen this in class recently. So EC, I've marked that on, was 8.1. DC was 5.4. And DB is 2.6. DB 2.6. Okay. Work out the length of AE. So I'm going to start, done this a lot in class, so I'm going to start by drawing out my two triangles. So let's draw out the big one. That is EAC. And the small one, that is DBC. And let's write on what I know. So I knew what DB was, 2.6, DC, 5.4, and EC was 8.1. Okay, so I can see that I have got this length here, which is similar on both. So I can do 8.1 divided by 5.4 to get me 1.5. So that's going to be my scale factor to get from the small one to the big one. So work out the length AE. Well, I can see I'm just going to do 2.6 times 1.5 to get 3.9. So that was okay. Then I'm told that AC is at 6.15. Work out the length of AB. So let's now draw on AC. So that is 6.15, and I'm actually going to draw on AC on my main picture here, 6.15, and I need to work out the length of AB. So let's just draw that one. I need to work out AB. Okay, so this time, if I've got a length on the big triangle, 6.15, what do I do to get the length on the small triangle? Well, do the inverse, right? Divide by 1.5. And 6.15 divided by 1.5 is 4.1. So 4.1 is BC. And I'm actually going to draw that onto my main diagram, 4.1. But my answer isn't 4.1 because what I actually want is AB. And because you can see I've drawn on the diagram, to get that, I'm going to just do the total length minus 4.1, which was 2.05. And that is me done. Move on to the next question. Okay, question 6. This is another question that I put a Corbett link for. It's a topic we haven't done in a while, but when these percentages questions come up, and we will revise them, but when they do come up, you should be able to get all the marks. So it says, Anil wants to invest 25k for 3 years in a bank. So let's just underline that now. It looks like he's got 2 banks to choose from. They're both compound interest. And the question says, which bank will give Anil the most interest at the end of 3 years? So let's do personal bank first, so PB. So 2% for each year. So each year, that means for 3 years, because he's investing it for 3 years. So just very quickly, I'll remind you how we work out the scale factor. So when we have percentage, we're increasing our money. So starting off with 100%, if I add 2%, I've now got 102%. And then converting that into a decimal, well, if I divide by 100, my scale factor is going to be 1.02. So what I'm going to do, I'm going to take my 2,500 and I'm going to multiply it by 1.02. But because it's for 3 years, it's going to be to the power of 3. And then if you put that into your calculator, you will get 26,530.2. And that is the first one. Now, what about Secure Bank, SB? So again, start off with the 25,000. This time, it's only 1 year of 4.3%. So that is 1.04. So that would be 4%. So 4.3% is just going to be 1.043. And then I'm going to get my answer, and then I'm going to times that by 0.9%. So that's going to be 1.009 to the power of 2, because it is for 3 years in total, and I've already done 1 year at 4.3%. So again, tie that into your calculator. That gives you 26,546.46. And when you compare them, the second one is higher, so you just say Secure Bank gives more interest, gives more. Fine, let's move on, but a good one to practice if you are not quite sure or can't quite remember how to do it. Great, so next one, a number n is rounded to 2 decimal places. The result is 4.76, and it's telling me to write an error interval question. So I know what I need to do here. I'm going to draw my number line. I'm going to put my number 4.76 in the middle, and then 2 decimal places. So I take my second decimal place, which is 6, and I add 1, and I subtract 1 to it, and then I'm going to find out the 2 numbers in the middle. So I think it's going to be 4.765. 4.755. Now I need to write it as an error interval. So I'm going to put those 2 numbers in, but I need to think about my inequality sign. So which one? I know one of them has the equal sign, and I actually think it is the first one, because it's on the first one, because if it was exactly 4.755, it would round up to 4.76, which is what I want. And it's not on the second one, because the higher number, 4.765, that would round up to 4.77. So I don't want that. So that is what my answer looks like. Let's move on. Okay, the cumulative frequency graph. Right, we've done that recently, so it should be okay. Shows information about the height of 60 students, an estimate for the number of students with a height greater than 160. So let's find 160 on my graph, and you should use a ruler. I'm going to do it carefully. I get here, and when I did this with the ruler, this was 48. but I actually want greater than 160. So I think I'm going to have to look at more than 48, or the difference between 60 and 48, and that is equal to 12. So you need to be careful that you subtract it from 60, which is the total number, to get your answer, which is 12. Okay, question 9. I got a diagram and I can see the word reflect and lots of different letters here, so probably gonna have to do quite a lot of work. It might be a little bit annoying. So Kyle reflects triangle A in the x-axis to get triangle B. Let's do that first. So x-axis, that is this one here. So let's reflect triangle A to get triangle B. Now I know when I'm reflecting a point in a line, I got to move the same number of squares away from the line that I moved towards it. So I've moved it 1 towards the x-axis, so I'm going to move it 1 away. It's going to end up here. So let's take this top point here, and I'm going to move it 1, 2, 3 to the axis. So 1, 2, 3 away. And then same one for this here. 1, 2, 3 towards the axis. 1, 2, 3 away. So if I draw up these dots, I'm going to get triangle B. He then reflects triangle B in the line y equals x. So you need to remember what that line y equals x looks like, and I've drawn on it there. So I need to reflect this triangle to get triangle C. And how I do this is I would actually turn my page so that the line y equals x is kind of a vertical line. So I'm going to kind of need to tilt my head to do this, but I would recommend that you tilt your page. So I'm going to show this as easily as possible. It's not easy to do on this computer, but let's try my best. So use a different colored pen. Let's take this point here, and I'm going to think, how many places do I need to move it to the line? Well, diagonally, I've got 1, 2, and a half. So I need to move it 2.5 away. There's the half, 1, and 2. Let's do the same thing for the other point. So this one down here, 1, 2, 3.5. So half, 1.5, 2.5, 3.5. This one here, 1, 2, 3, 1, 2, 3. Okay, that is triangle. That is triangle C. It then says Amy reflects triangle A in the line y equals x to get triangle D. Okay, so back to triangle A. I'm going to reflect it in the line. So using green, that point stays on the line. This point here, I just move a half to get the line, so a half away. And this point, I go 1.5, so half and 1. So this is triangle D, and then I reflect this in the x-axis. Okay, I'm just going to get rid of some of my lines here to make this easy. Okay, I'm going to reflect triangle D in the x-axis. So how do I do this? Okay, so again, 1, 2, 3, 4 to the x-axis. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then finally, 1, 2, 3, 1, 2, 3. And that is triangle E. Amy says that triangle E should be in the same position as triangle C. Well, look at C, look at E. I'm just going to say no, they are in different places. They are in different places. As shown. Don't need to say anything more than that because I've shown where they've ended up. So that is enough to say. So that was a bit annoying, a bit fiddly, but actually, if you're confident with your reflections, should pick up all the marks there. Let's keep going. Okay, question 10. This looks like a standard form question. We got some information about 8 planets. Write down the name of the planet with the greatest mass. Well, I did this in science, so I know it's Jupiter. But let's just check. So when I'm comparing to see what the biggest number is, I actually think I need to look at my powers of 10. So whichever one is the biggest, that tells me how many zeros it's got. And because Jupiter is 10 to the power of 27, I know that it is going to be Jupiter because it's got the biggest power of 10. Find the difference. Okay, so difference means subtract between the mass of Venus and the mass of Mercury. So this is going to be easy because I got a calculator. So I'm going to start off with Venus because that's bigger. And I'm going to write down my working out. And all I'm going to do is plug this into my calculator. And my answer, just going to write it out. Easy 2 marks or just 1 mark to get there. Puzzy, Nishat says that Neptune is over 100 times further away from Earth than Venus is. Is Nishat right? You must show how you get your answer. So I'm looking at distance from Earth. 100 times mean I'm probably going to need to divide to find out how many more times further away it is. So start off with Neptune, 4.35 times 10 to the power of 9, divide by Venus, so that was 4.14 times 10 to the power of 7, and I get 105, which is bigger than 100. So yes, she is right. Or he. He is right. Let's keep going. Right, I've got algebraic fraction 1 to do. So when I do this, I know that my denominators need to be the same. So what goes into, or what do 4, 3, and 6 all go into? They go into 12. So I'm going to write all my denominators as over 12. Okay, how do I get from 4 to 12? I'm going to times by 3. So 3, open brackets, 3x minus 2. How do I get from 3 to 12? Times by 4. So 4 brackets 2x plus 5. And how do I get from 6 to 12? Times by 2. So 2 open brackets 1 minus x. Now I've made my denominators the same, I can basically cancel them or not think about them, cross them off. And now I'm going to expand brackets. So the first one, 9x minus 6. And I'm actually going to put everything in brackets here because I need to be careful with my positive and negative signs. So the next one, 8x plus 20 equals 2 minus 2x. Now let's get rid of my brackets. I need to be careful here. We've got 9x minus 6. Now imagine there's a hidden 1 in front of the brackets. So minus 1 times by 8x is minus 8x. And minus 1 times by 20 gives me minus 20. Minus 20. 2x. Collect like terms. So I've got 9x minus 8x, that's just x, and minus 6 minus 20, minus 26, 2 minus 2x. So now I'm just solving an equation with x on both sides, so plus 2x to both sides. And I got 3x minus 26 equals 2. Add 26 to both sides. 3x equals 28. And then finally divide by 3. So x is, I can leave it as a fraction, 28 over 3. Okay, so question 12 is a tree diagram, and we are asked to write down one thing that is wrong with the probabilities in the diagram. So let's go back to the question. It says there are 30 students in the class, 16 are boys, so 14 girls. And then it says 2 students are chosen at random. So I think I can see a couple things wrong. So for these two probabilities here, I know that they have to sum to 30 out of 30. They have to sum to 1. But actually, I think the problem is that this denominator here should be 29. Because in the second pick, well, you've already picked one student, and so there are 29 students left. So I'm going to write down the denominator in the second pick should be 29. Next question. Owen and Wazim play for the school football team. Mr. Slater says the probability that both boys will score a goal in the next match is 0.4 plus 0.25. Well, I'm going to say he is wrong. No, because I know that when I've got two independent events, I need to multiply. So I'm going to say what the probability should be. The probability should be 0.4 times by 0.25. All right, question 13 is a histogram question. We've done this a lot recently. So the histogram shows some information of the ages of 134 members of a sports club. Okay, that might be useful later on. 20% of the members of the sports club who are over 50 years of age are female. Work out an estimate for the number of female members of who are over 50 years of age. Okay, so I think the histogram is just telling me about all of the members, both male and female. So if I work out how many are over the age of 50, then I can just do 20% of them. So let's find 50 on our frequency diagram, and I'm going to draw a line up from here. And I know that, so step 1, frequency is the area of a histogram. So it's the class width times by the frequency density. So I need to work out the area of this rectangle and this rectangle. So what's the first rectangle? So a rectangle. So that is going to be 50 to 60. So from 50 to 60, the class width is 10, and the frequency density is 1.4. So that frequency is 14. And then from 60 to 90, the class width is going to be 30 times by, I think that is 0.7, so 21. So my total over 50 is equal to 14 plus 21, which is 35. And then my second set, well, 20% of them are female. So 20% of 35, I can just do 0.2 times 35, and I get my answer, which is 7. Let's keep going. Okay, so question 14, here are some graphs. Now, some of these graphs we actually haven't covered yet. So we'll do the ones that we have, and then I'll talk through very quickly the ones that we haven't. So we have looked at this bottom one here, which is a reciprocal graph. And I know that this graph looks like this because it's a positive reciprocal graph. So the one that looks like that is, I think, H. So we will put H for that. And the other one that we've done is the second one. This is a cubic graph because I got the x cubed, positive cubic. And I think this one looks like this, or it could look like this as well. So which is the one that looks like that? Well, that is F. But the other two we haven't really done. So the sine graph, y equals sine x, sin x, or sine x. I'll tell you, and we're going to do it in class later, that is graph C. And then y equals 2 to the power of x. Well, you could actually figure this out if you substituted some values of x into it, but that is graph A. But we are going to look at that in more detail in coming lessons. Let's move on. Okay, A, B, C, and D are 4 points of the circumference of a circle. And we're asked to prove that triangles ABE and DCE are similar. Okay, so the first thing I'm going to do is I'm going to highlight ABE. Highlight ABE. So that is ABE. And different color, I'm going to highlight DCE. So I need to prove that those two triangles are similar. Now actually to do this, so we've done lots of work in class on congruence proof, but if two triangles are similar, they're not necessarily the same size, but they do have the same angles. So for example, this triangle and this triangle, they're different sizes, but they're similar because all of the angles are the same. So I need to show that the angles, some of the angles are the same to show that they are similar. So which two angles are the same? Well, I think the first one that jumps out to me are those two. So AEB equals DEC. And the reason is that vertically opposite angles are equal. And there's another pair of angles which are the same. And actually, I need to remember my circle theorems for this one. So I kind of got what looks like a bow tie. And you can see I'm wearing a bow tie as well. So I think this angle and this angle, I'm going to use my bow tie theory. So angles in the same segment are equal. So ABE equals ECD. Angles in the same segment are equal. And actually that is enough for my proof, because if two angles in the triangle are the same, then the third one is also the same, because angles in a triangle sum to 180. But I could also say, if I wanted to, that BAE equals EDC for the same reason. And then my conclusion is therefore ABE and DCE are similar, because I've shown that they've got two or three angles that are the same. Okay, question 16. Using algebra, prove that 0.136 recurring times 0.2 recurring is equal to 1/33. Now, this is another question that I've put the Corbett video in, because it's something that we did last year, but and there's actually a question on the recent mock on it, but a lot of us forgot. So let's just go through this first one here. So I'm going to let x equal the first one. So that is 0.1, and then the 3 and the 6, and then the 3 and the 6 repeat. Okay, so I know that if I've got one number after the decimal point, so that's my number after the decimal point, I need to take 10x to get rid of that one number. So if I do 10x, then that is equal to 1.36, 36, 36, etc. And so the other thing that I need to multiply by is I need to multiply by 1000x. And the reason for that is that if I want to get the same recurring pattern after the decimal, that is 36, 36, 36, I need to multiply the 10x by 2 decimal places, or by 100. So 10 times by 100 is 1000x. And that is 136.363636. Now you can see that I've got the same recurring pattern after the decimal point. So I'm going to subtract. So I got 990x equals 135. And now I divide by 990. And I have x equals 135 over 990, which simplifies to 3/22. Just pop that in your calculator and it simplifies to that. Okay, now I've got 0.2. So I can say let x equals 0.2 recurring. And this is actually an easy one. I've just got that 2 recurring, so I can say 10x equals 2.222222. I'm going to write x underneath that, and I can see that I don't need to do that much work. Subtract them. 9x equals 2. X equals 2/9. And now my final part is I need to prove that when I multiply them together. So 3/22 times by 2/9. And you can write that in your calculator. You are going to get 1/33. And you're done. So if you need to practice that, go to Corbett video 96, because it's very common that these type of questions come up in the paper. Question 17. Okay, I've got a sector of a circle here, and looks like a triangle as well. So let's read the question. ONQ is a sector of a circle, center O and radius 11. So I'm actually straight away going to mark on that radius here and here. A is the point on ON and B is the point on OQ, such that AOB is an equilateral triangle of side 7. Equilateral triangle, so all of the lengths are equal and all of the lengths are 7. So this one's 7, this one is 7, and so is this final length here, 7. And I also know something about the angles in an equilateral triangle, and let me just add that in. So my angles, my blue angles, are all 60 degrees. They're all going to be 60 degrees. Okay, then it says calculate the shaded area as a percentage of the area of the sector ONQ. So I need to find the area of the shaded region. So area of the shaded region. Well, to do that, I'm going to need the area of the whole sector minus the area of the triangle. That's going to be my shaded area. So how do I do that? Area of the sector first of all. So I know how to calculate the area of my sector. I've got 60 out of 360 because that's the fraction of the triangle of the circle that I have, times pi times radius squared. My radius is 11, and that gives me 121 pi over 6, and I can write that out as a decimal, 63.355, etc. Now my triangle, well, you need to remember your formula for area of a triangle, which is one which is not right angled. It is a half AB sine theta, where theta is this angle here, and A and B are your sides, which are either side of the triangle. So A and B are both 7. So the area of the triangle, half, times 7, times 7, times sine 60 equals 21.2167. Therefore, the area of the shaded region, I'm going to subtract them. So 63.355 minus 21.2167, 42.1374 centimeters squared. So that's the area of the shaded region. Now I'm going to do, it says the area of the shaded region as a percentage of this area of sector ONQ. Well, I've actually worked that out already. So this is my shaded region, 42.1374, as a percentage of, so divided by, well, that sector was 63.355. And to convert it into a percentage, I need to, of course, times by 100. And my answer to one decimal place was 66.5%. So quite a nice question there. The key in that question was realizing that I have an equilateral triangle. So I knew all of the side lengths of that triangle as well as the angle. which I needed to find the area of the sector that the triangle was inside. Okay, great. I've got an indices question now. So the first thing I've spotted here is that all of my base numbers, so the 16, the 2, and the 8, they are all powers of 2. So my first step is going to convert them into powers of 2. So 16, I'm just going to write here, 16 equals 2 times 2 times 2 times 2, or 2 to the power of 4, and 8 is 2 to the power of 3. So instead of, let me just write out my original equation again. And then instead of 16 and 8, I'm going to write 2 to the power of 4. The 2 to the power of x doesn't change. And instead of 8, I'm going to write 2 to the power of 3. Great. Now I'm going to get rid of my brackets. So just remember the index law, which is if you've got x to the power of a to the power of b, you multiply the numbers. So I'm going to need to do that with my 2 brackets here. So step 2. Well, 4 times by a fifth is 4/5. Let's do that working here. 4 times a fifth, well, 4 is just 4 over 1, which is 4/5. You can also put that in your calculator, but you don't really need to. Times by 2 to the power of x, and then 3 times 3/4 is 9 over 4. Great. My next step, well, now that my bases are the same, I can now compare my coefficients. And I can set up an equation. And what I need to remember for this step here is that if I'm multiplying indices of the same base, I add the indices. So I need to remember this. So what does the left-hand side look like? Well, I can ignore the 2, but I need to add the powers. So 4/5 plus x equals, again, ignore the power, 9 over 4. And then in my calculator, I can do 9 over 4 minus 4/5, 29 over 20. And I'm done. Okay, next question, another algebraic fraction. I actually had an equation earlier with algebraic fractions, but this is one, it's not an equation, I just need to simplify it. So if you know what to do here, it is a good question, which is why I put Corbett 21 in here, so that you can practice with your algebraic fractions. So first thing I'm going to do, just to make my working out a bit clearer, is I'm going to rewrite the question. Okay, and I'm also going to write the 2 as 2 over 1, so that I've got 3 different fractions. So my first step, I think, is to work out my common denominator. And to do that, generally, what I do is I multiply together my terms, particularly if they're algebraic. So I think it's going to be x minus 3, x plus 3. So let me just write that out for all 3 of my terms. X minus 3, x plus 3. Great. So now I need to figure out what my numerators are. So the first one, I think it's just going to be 2 brackets x minus 3, x plus 3. The next one, well, how do I get from x minus 3 to x minus 3 times x plus 2? Well, I think I'm going to multiply by x plus 3. So that's going to be x plus 2, x plus 3. Next one, how do I get from x plus 3 to x minus 3, x plus 3? Well, I'm going to multiply by x minus 3. So that's going to be x minus 6, x minus 3. Okay, and now I need to expand everything that I have got on my numerators. So basically what I need to do is I need to do 3 boxes. So let me do that very quickly. So the first one, x minus 3 and x plus 3, x plus 2, x plus 3, x minus 6 and x minus 3. So do this very quickly. Okay, so ready to move on. So the first one is 2 times by x squared minus 9. The next one was x squared plus 5x plus 6. And the next one was x squared minus 9x plus 18. And it's going to be all over, x minus 3, x plus 3. Okay, so now I need to simplify the numerator. So I've got 2x squared minus 18. And I'm going to be careful with my negatives here. So minus x squared minus 5x minus 6. And then the next one, minus x squared plus 9x. Because it is negative, it's minus 9x minus 18. All over. And I'm just going to write x squared minus 9 because the question wants it in that form. And now I just need to collect like terms. So I've got 2x squared minus x squared minus x squared. So 2x squared minus x squared. So that's actually 0x squared. Then I've got plus 9x minus 4x. So that is 4x. And then minus 18 minus 6 minus 18, that is minus 42 over x squared minus 9. So what's my value of a, my value of b? So it looks like a is 4 and b is minus 42. Okay, almost there. Okay, so this next one is a tricky one that we haven't really covered before, so we will cover it at some point, but I'll go through it anyway. It says, the diagram shows part of the graph of y equals x squared minus 2x plus 3. It says, by drawing a suitable straight line, use your graph to find estimates for the solution of x squared minus 3x minus 1. Okay, so what I'm going to do is I'm going to write out the equation that they've given me. And I'm also below going to write out the equation of the graph that I am going to get it from. So that is x squared minus 2x plus 3. And so if I need to use this graph, I need to figure out how to get from the equation they've given me to the graph that I have. So how do I get from minus 3x to minus 2x? Well, I'm going to add x. So I need to add x to both sides. And how do I get from minus 1 to plus 3? I need to add 4. So actually, if I plot the both graphs, y equals x squared minus 2x plus 3, which I've already got, and y equals x plus 4, which I need to plot, then the solution is where these two meet. And I can read off the graph. So let's plot the graph y equals x plus 4. It's pretty straightforward. My table of values, pick 0, 1, 2, 4, 5, 6. So let's plot these points. 0, 1, 5, which is here, and 2, 6. So if I plot this line with a ruler, then these 2 points where they meet are my answers. So my first answer, I did it properly with a ruler earlier, and I got 3.2. That was that one there, 3.2. And then this one, I got minus 0.3. So x1 was 3.2, x2 minus 0.3. So that's a tricky one, but hopefully the way that I explained that made sense, and we will go over it again at some point. Part B. P is the point on the graph of x squared minus 2x plus 3, so the original graph where x is 2. Calculate an estimate for the gradient of the graph. Okay, so for this one here, what we actually need to do is draw a tangent to the graph at the point x equals 2, so something that looks like this. So once we draw that tangent, we can find the gradient of that tangent. So the tangent, by the way, I drew it at where at the point x equals 2, where it just touches the graph, and it's that straight line. So if I actually find, let me just use a different color for this. If I find the gradient between 2 points, so this point here, so 2, 3, and I think this point here is good. So if I find the gradient, which I know is change in y over change in x, then I'm going to be good. So my change in y, I think, is going to be, well, how do I get from 3 to 6? From 3 to 6, it is 3. And what was my change in x? Well, to get from 2 to 4, it is 2. So my estimate for my gradient, 1.5. Okay, question 21. 3 more questions to go. The diagram shows 3 identical circles inside a rectangle. The radius of each circle is 24, and I need to find out the area of the rectangle. Okay, so area of the rectangle, that's easy. I know it is the base times by the height. So I need to find the base multiplied by the height, and I'm going to be good. So what can I draw in? Well, the radius of each circle is 24. So let's draw in those radii. I'm going to draw it across here first. And actually, these are all 24. So I think that my base here is going to be 24 times by 4 is 96. So actually finding the base was easy, but finding the height is not easy because the circles kind of overlap each other. But what I'm actually going to draw on is I think that if I connect the radii here, I've actually made a triangle, and I can write in some of these radii. So all of these radii are 24, 4, 24. And actually, let me draw out this triangle again. And I think that this length here is 48. This length here is 48. 48 here. And to find the height of the rectangle, what I'm going to need to find, I'm just going to change to a different color, is that I know this length here, because it's a radius, is 24. And so is this length here is 24. So what I actually need to find is this length here, or on my triangle, this length here. Let's call that length x. And what I've actually done is I've actually formed a right angled triangle where this length here is 24, So let's draw out this triangle that I've made for myself. So 24, 48, and x. And I think to find x, I can use Pythagoras' theorem. A, B, C. So a squared plus b squared equals c squared. X squared plus 24 squared equals 48 squared. Let me just get my answer out in front of me. So I do this and I end up as x being equal to 24 root 3. So let's write that on my diagram. That height there was 24 root 3. So my total height, I'll do it in green here. Well, it's going to be 24 plus 24 root 3 plus 24. And therefore, rest of it's easy. My total area is my base times by my height, which was 48 plus 24 root 3, which was something that's like this. But three significant figures, my answer was 8,600 millimeters squared. So quite a nice question. Actually, I managed to figure out because I drew on lots of additional lines inside my diagram and actually formed a triangle which helped me to find that key length of 24 root 3 in my working out. So by sort of drawing out these two separate diagrams, my question became a lot easier. 2 questions to go. Okay, second last question, almost there. And this is something that we did last year a while ago, quadratic sequences, where if you know what to do here, this is an easy 3 mark. So just going to write out my sequence again. And by the way, if you go to the Corbett video, I haven't looked at it, but different math teachers have different explanations for what to do. So they might explain it in a different way to me, but this is the way that I taught you. So I'm just going to go through that now. So I'm going to find the difference in my terms, and then the difference of the differences, which is +4. So what that means is if my second difference is +4, this means that 4 divided by 2 is 2. My sequence starts off with 2n squared. So it starts off with 2n squared. Now my second step is I need to write out, if this is my original sequence, I need to write out my 2n squared sequence. Now, an easy way of doing that is to write out my squared terms and then double it. So my square numbers are 1 times 1, 2 times 2, 3 times 3, etc. And when I double them, 2, 8, 18, 32, and 50. Once I do that, my final step is to take my original sequence, subtract 2n squared. So I'm going to do 4 minus 2, which is 2, 11 minus 8, which is 3, 22 minus 18, which is 4, etc. And I need to find the nth term of this sequence. Well, it goes up in 1, so it's just 1n. And then to get from 1 to 2, I add 1. So I'm going to add this n plus 1 onto my 2n squared. So my final answer is 2n squared plus n plus 1. So this is a technique that I taught you, but they might have explained it differently in the video. So go have a look and go practice getting these questions correct, because if you know the process, you should be getting 3 marks every single time. On to the last question. Okay, so I was just in the middle of recording the final question, and my pen that I used to do my writing on my computer ran out of power, and it's about to be the KSA staff Christmas party. So I'm afraid I'm going to have to leave the recording there. But actually, the last question was the equation of a tangent to a circle, which we've done very recently in class. So actually, it should have been quite a nice question for you. And there's a video and a model answer on Maths Genie. So you just need to go to that paper and have a look at that to check your answer. So leave it there. Hope you've gotten lots out of this. Do make sure that if there's any of the questions that you couldn't do, you go to the Corbett page so that next time you will get the questions right. Thanks very much for watching, and have a good rest of your day or weekend.